Good morning, everyone. It may not be morning to you, but I got up really early and flew in from Copenhagen this morning because getting from Norway to Finland this early is actually quite difficult. So I flew to Copenhagen yesterday evening, spent 30 minutes walking to a close-by hotel because everyone close were closed. So, in fact, it's still morning to me. And I saw there was no coffee, so I hope that you still are able to listen to me for 28 minutes and 46 seconds. All right. My name is Eirik Valderhaug. I'm Norwegian, as you probably guessed by now. I'm with the Cortex team. I'm a system engineer specialist, and I'm going to walk you through a bit about the Cortex XDR system that we are, together with Elisa, doing quite some stunts with right now. So, first of all, I'm going to talk a little bit about why we even have this kind of product portfolio. And of course, it stems from a need. And the need we're going to talk about also stems then, of course, from the challenges that we see in SecOps. So obviously, this is something that we've seen in the cybersecurity space for quite a while. The number of attack vectors and the advancedness of those attacks, of course, grow all the time. So this is nothing new, but of course, it does come up to a certain amount that makes it really difficult to address in an efficient manner. So if we look at why security teams struggle today, after talking to, of course, a lot of customers and so on, these are primarily the three main topics that it breaks into. So the first topic is the sheer number of alerts that you get every day, every week, every month to handle. There are so many alerts coming in from various tools that you just don't have the manpower to cover them all. And this, of course, leads to gaps, detections that you don't see, etc. The next point is that a lot of customers have a lot of different products in order to address the issues. And it looks that more than 30 point products, especially in the bigger customers, are present in their locations worldwide. And this, of course, makes it really difficult when you manually have to pivot between all these different products to try to piece together what's going on. And then, of course, it's the lack of context. If you see something happening on one product, that doesn't give you enough data to figure out what exactly happened. So then again, you have to go to look at different sources, try to piece what is important from the different products you have, and this takes days, weeks, even months in some cases to figure out. So what's actually going on? What does it look like? And this is sort of what it looks like today. So it all starts with an alert, typically, and this spins off a whole chain of events, of teams, of products, of connections, conversations, and so on, and it's messy. It's really messy, it's complex, it's manual, it takes a lot of time and effort, and obviously this doesn't scale when you have hundreds of thousands of alerts per week. So what we're seeing is that we need to transform the SecOps. So where most of you and the customers in general typically are is in the green spot, where basically you are in a reactive mode. You're looking at alerts as they're coming in. You have rules to detect whether or not something bad happened. There's a log aggregation going on, but there's no automation. So this means that it usually takes a lot of time to find and respond to an attack. And this is really inefficient. It takes a long time to figure out what happened and then to respond, and it takes a lot of manpower. So what we're seeing is the need to move to the right through, of course, stages, and ending up at a stage where it takes a lot less time to detect what happened and to respond to it, so that we become more efficient and have a fully automated response. So XDR is here to ensure, together with Elisa, who provides this as a service as well, to make sure that you actually drive and end up in the right area, which will make your SecOps a lot more efficient, and of course then being able to detect and respond a lot faster. So how do we do this? What's our unique approach to dealing with this? So first of all, everyone who has heard about Palo Alto at one time or another know that we're really focused on prevention. and we're going to continue to focus on prevention. If you can stop something before it actually manages to do anything bad, then you save yourself a lot of time and effort. So of course, we're still doing everything we can to prevent the attacks from happening. And we do this with our traps agent, that's our endpoint protection on servers and workstations, etc. And of course, we still have our firewall, which does inline prevention at the network layer. And we do a pretty good job at this. We prevent most things. But even the best solutions out there can't prevent absolutely everything. So for the most advanced attacks that span different vectors, we have XDR. And XDR, using AI and machine learning, will detect attacks that are extremely advanced, that take, for instance, days to achieve, and it will do this in a manner which makes it easy for SecOps to discover it as well. And then we augment the information we get with our autofocus solution, which allows you then to proactively look for other vectors that could potentially be used for further scanning and so on. So this saves a lot of time and effort. But if you truly want to get everything up to speed, make it faster and so on, you also have to look at automation. And that's where Demisto comes into play. So Demisto is the part of the puzzle that looks at everything and runs playbooks based on what's happening. And a playbook is sort of a script or a recipe which says exactly what's going to happen if, for instance, you get a phishing email. That pops off, for instance, alerts to your admins. It might send an email to the user saying that please don't open this email. It could lock out the user from AD or require a password chain and stuff like that automatically. And this saves a lot of time for, of course, SecOps, so they can focus on the most important stuff, is seeing what actually happened and was it bad. And Elisa have this complete offering now with XDR, traps, Demisto, everything, and it's really easy to test. So if you want to test this, just get in contact with Elisa and they'll help you to get a proof of concept, eval, up and running. That's really fast to get out there. So now I'm going to cover a couple of use cases, specific use cases where we come into play. So standing at the endpoint, so if we look at the state of the union today, you can see obviously that the legacy systems and security systems have failed. They're using much the same tools as we did 10 years ago, while attackers, of course, have moved on long since. So they just don't cut it in terms of how to prevent and stop attacks. And they also spend a lot of CPU cycles and drain the systems of much needed resources to do their jobs as well. We also see that they just focus on the endpoints. So the endpoint just looks at the endpoint and doesn't do anything else. But like I said before, some of the more advanced attacks span both the network, cloud, and the endpoint. So in that case, it's necessary to make sure that we integrate between the endpoint and the network and the cloud as well. Now, many vendors have realized that we need more than just prevention, so they will do EDR, endpoint detection and remediation or response. But then again, even if it's a good idea, you're still just looking at the endpoint. And in order to see the full picture, you have to consider the network and the cloud as well. So take a quick example of how an attack normally would happen today. So a lot of these days it starts with a phishing email. You click on a link, you're tricked into giving up your credential, might be landing at an exploit page. The user then logs into your machine, uploads malware, which then exploits vulnerabilities, infects the local endpoint, moves laterally, looks for servers or SQL databases to steal, and then typically in the end extracts data that is valuable to someone. Especially you, of course. So with traps installed, we can protect on all these different layers. So not just looking at what typically AV does at signatures, we don't use signatures at all. We look at the actual techniques that are being used. So we can block and prevent both known and unknown attacks on different layers throughout the entire cycle. So we can stop the attack even at the beginning to look for the exploit technique. We can block known and unknown malware. And again, we can exploit techniques happening at the later stage. We look for behavior patterns that we block if they're malicious. This stage is also very important because a lot of attacks today are what we call fileless attacks, meaning they're using Windows, typically, processes that are benign, like PowerShell or Command XE. So these aren't malware, but you can abuse them. So this stage looks for abuse of legal processes. And of course, we provide all we find, the data, everything from the endpoint to XDR for extended investigation, which is again something that Elisa also provides with Cortex. So what Traps offers is, like I said, a very, very good prevention. Stops most attacks out of the box, 99%. And will then allow you, of course, to sleep better at night because it will block both known and unknown attacks. The second part is if it finds something that, for instance, your firewall can use as well for protection, it will share that information via what we call wildfire. So if Traps finds a new malware that's never been seen before, it will share that information with the cloud, which will then generate signatures for the firewalls all around the globe. And this happens automatically. There's no admin interaction, and vice versa. If the firewall finds something, then Traps will be able to look up this information on demand when a user tries to launch that malware. So we keep the information shared between both the network, the endpoint, and cloud automatically. And then, of course, we also look at the data in the context of a whole network, not just, oh, this happened on the endpoint, it doesn't matter anywhere else, because we know it does. So making sure we have the detection and response for the entire network is something that's really, really important. Now, if you look at threat detection, what are the problems today? Well, first of all, realize, like we said before, no solution can block everything. There's always something really advanced, something we didn't know about at some point that potentially could get through. And I'm not saying all the other solutions are bad, but if they generate that many alerts, it's entirely possible that because humans are looking at this, that they won't even be able to see it in the just sheer mass of logs. That's what happened to Target in the US, by the way, a couple of years ago. Cost them like $500 million, so it's a little more than pocket change. They actually got the alert, but because it was part of 30,000 other alerts, they just didn't see it. So obviously, that's a big problem. And the last part is that, like I said, first, the number of alerts, and the other one is how do you connect the dots when there are so infinitely many dots to connect? That's when we use machine learning. And the attackers are using machine learning as well. They're using AI to perform their attacks as well. So we need to meet that with the same kind of firepower. So today, when you do threat detection, a human then, of course, has to do a lot of the heavy lifting. So we'll have to look at data from the network, from the endpoint, from the cloud, typically across multiple products. And then he has to find out, okay, we had this incident here. How does that, if at all, map to what's on here? And if you have then thousands of alerts here, and here, not to mention that you also look at the log that are not alerts, just to see what actually happened, this becomes a huge and very, very time-consuming job. So what we're doing with XDR is that we're taking all the data from the endpoint, from the cloud, and the network, and we send it to what we call the data lake. The data lake is basically where we store the information, and it's unique to every customer, obviously, so we don't share it with anyone. And on top of this data, we use machine learning to look for what's the common behavior for each user on each machine in the entire network. It has no predefined, this is how it should look like, because that's different for every customer. So it's completely blank at the start and use only machine learning to learn what does your user on this machine typically do. And of course, it changes over time because we adapt new products and so on. And you will start using, maybe you'll merge, go from Outlook to Gmail. Don't do that. We did that. That's not a good thing. And of course, you can create your own custom rules, and it will lead to what we call high signal alerts. And there will be a lot fewer of those than what you would see in a traditional solution, because we get high value data, and we know the correlation between all of these. So what we'll provide is basically very high quality, useful alerts. And it will be much easier for your analysts to look at that. So we'll take a look at that. So what XDR provides is the full visibility. So we see everything on the network, on the endpoint, on the cloud as a whole. And we'll see some visual examples of what that actually means. But when you look at it as a whole, you will also be able to see much more advanced attacks that otherwise would go under the radar. We also have, specifically now, a third-party test called Microattack, which is quickly becoming the de facto test for endpoint protection. It's completely unbiased. It doesn't provide any reports or anything, except that if your product blocked or didn't block a specific vector. And I encourage everyone here to come and see us, and I'll show you the results that we combined on how well we did on the attack vector testings in there. And these are basically much more what I would see harsh on the environment than normal AV tests. So these basically hit your endpoints a lot harder and are much more difficult to survive, basically. And then, of course, one of the things that I like about Palo Alto is that we do acquire best-of-breed technology. But we don't just slap a label on them and say, now it's Palo Alto. We actually take the products off the street, if it's necessary. With Traps, we spent 8 months just making sure it was properly integrated before we launched the product. Anyone can say that, okay, I'll just send the syslog to a same server and now it's integrated. But real integration means that it goes both ways and that it is properly integrated, so that you don't have to spend time jumping back and forth looking at different things without actually having the full context. So our technology is best of breed, and we made sure that everything we acquired is properly integrated. So how about investigation and response once we actually have an alert? So the challenges, again, goes back to today. If you have an alert in one product, you have to spend a lot of time looking at the other products that don't make alerts and so on, to see what happens. Basically connecting the dots. Takes a lot of time, hours, days, weeks. And again, it's manual. And in many cases, the incident handlers actually have to build their own rules or tools even to gather all this data to try to speed things up. Very, very manual, very, very time consuming. And if something changes, well, then it's back to square one. And the last part, and this is extremely important, is finding out the root cause. Where did it actually start? Just because your firewall says, okay, we see an attack here, well, where did it start? Did it start on a machine? Which process ran it? Was it started by some external entity? Was it lateral movement? We have no idea. That's why it's important to have all these things interconnected, so you can get to what we see here. So like I said, in normal environments, you have a lot of different points which will generate alerts, and you have to jump back and forth and try to figure out which one are connected and how did it happen. In XDR, you get this. We digest everything from the endpoint, from the firewall, from the cloud, and automatically build what we call a causality chain. That means that when your responder takes a look at it, he will see this visualized. It started with Chrome with a phishing email, which spawned a decompression engine, which then spawned command, which spawned PowerShell, which ran the script that was embedded in the zip file. This takes 8 to 10 hours to do manually for even a highly skilled analyst. In here, it takes 2 seconds, and it's done automatically. It saves a lot of time and gives you an immediate understanding if, is this actually bad, or was this something that was supposed to happen and we can ignore it? And this is also something that Elisa provides as a managed service, the entire review of this and the response as well. So what do we sort of bring to the table? So the first of all is that we make sure that the incidents you do get are grouped. So we don't give you 20 different alerts if they all are basically the same attack. You'll get one, which then contains all the different information for your analyst to look at. The other part is that you don't have to pivot between the firewall, the endpoint, or the cloud. You'll get everything presented in one view. If you want to look at what a process did on the network, you'll click on the network tab and you'll get all the information immediately. Instead of then logging onto a second firewall and then looking at that, and maybe even a second firewall which is behind that one, and logging on and trying to figure out the exact, takes a lot of time. Here it just pops up. And the root cause. There's no question about what the root cause was because you get presented it immediately. It started with a phishing email, went through all the stages, and then finally ran a script. Then you can know, where do I need to go? Where did it start? Can I do something about my security posture to prevent this from happening again in the future? And you can do that immediately. So, XDR. Anyone want to guess or even know what X stands for? I'm seeing a lot of hands. I wasn't expecting that either. It's kind of scary to do that, right? So we have EDR, endpoint detection and remediation, or response, depending on. So of course, Palo Alto, being humble, we want to be better than everyone else. So the X sounds cool, and also it means that any source. Because we're not just looking at the endpoint. We're looking at the network, the cloud, etc., which is why we call it XDR. So, XDR then, of course, combines the prevention, the sheer amount of data, the machine learning, the automation for root cause analysis, and the integration that is required to get from the left stage to the right stage of where the SOCs want to be much, much faster in mean time to respond and detection, and hugely automated. So this will provide that functionality for you. So like I said before, we'll get the logs from your firewalls, from your endpoints and your cloud services into a single data lake. And on top of this data lake, XDR will use its machine learning and its other features to look for strange behaviors, specific attacks, unknown attacks, and do it really efficiently and provide very easy and automated context for the analysts. By doing this, we can then, of course, combine all these, until now, separate functions like endpoint protection, network threat analysis, EDR, UBA, into one product. Traps is and will still be highly focused on preventing stuff first and foremost. That's for the malware, of course, and also for the exploits, but we'll also be sending all the information that we get to the data lake for analysis as well. XDR will provide high-quality alerts that are pre-built with all the context you would need, saving a lot of time, making it much easier for humans to look at this. It will, of course, allow you to build your own rules. We don't think that we know absolutely all the use cases you might possibly have. So, of course, it will be very easy for you, or in conjunction with Elisa, to build specific rules. Fun fact, first customer we had in Norway, they wanted to know if their users, when they plugged in a USB stick, if they ran anything but MP4 files. Don't ask me why they did that. It was a vessel company, I have no idea. But we easily create a rule so that if anything is being read from the USB stick, anything not C:, please alert us. And wouldn't you know, they actually did that. So they were happy. Took us 2 seconds to define the rule, and then 1 minute to just create it. Really easy. And again, hunting. Not everyone wants to do hunting. hunting is basically looking for something that's not part of our already made rules and so on. And they're built exactly the same way as rules, which makes it really easy as well for customers and so to look for specific things. So we're not going to do a live demo here, but we'll be able to do that both at the Elisa's booth and our booth if you want to take a deeper look. These are just quick screenshots directly from the solution. Here we can see the grouping functionality that's going on. This is the root cause analysis I mentioned, where everything is built automatically. And if we scroll down, you can see all the deeper information about the network connections, manipulations doing to registry, and so on. And we also have the ability to log on to a machine remotely and perform functionalities there as part of the response. So the value we're bringing is, of course, it takes a lot less time to find out what happened and if it was indeed an actual breach. That saves time, of course. We'll present a lot fewer alerts to those who manage this, and that will, of course, make their lives a lot easier and also make them able to handle more alerts. And of course, if we can enable this, that means that you can stop attacks from spreading a lot faster, and that will hurt less financially as well. So we have a TCO reduction of approximately 40%, and we have the calculation for that as well. And the last part I'm going to do before I open up for questions is to show the Microattack results. So as I mentioned, the Microattack is a really harsh test for which kind of attack vectors techniques are we able to detect. And as you can see, we're not just a little better, we're a lot better than the next one on the list here. Now, the first time I saw that, I thought, this is really excellent. And my next thought was, does this mean that we missed 12%? So let me give you the context around this. In this test, we're not allowed to do prevention. This test only shows what we are able to detect. But I was still thinking, well, represent, in many cases, an attack vector. Because an attack is not just one and then done. There are multiple. So once we turned on prevention here, this went to 100%. Because we only need to break one piece of the chain to stop the entire attack. So none of the attacks went through when you turned on prevention. So this was just a test of unique attack vectors, but you typically have to have multiple different vectors in order to achieve your objective. So with prevention on, we stopped everything. Now I have 1 more minute, I think. That's what it says, the red thing here.
1 more minute for one question.
One question and a long answer. I see a lot of hands going up here.
Please, anyone?
Yeah.
Just a sec. Okay. You get the mic.
Thanks. How much log do you need to provide to the cloud environment from your company computers?
Excellent question. So it's twofold. For the protections that are based on rules, because one is machine learning and the other one is what we call BIOCs. BIOCs work straight out of the box. The very second you send one log, it's active. For machine learning, we typically spend 21 days learning each user's behavior to the fingertips. It will detect stuff before that, but after those 21 days, we have a really solid fingerprint for the user, and we have a very, very high quality, which we expect approximately 1 alert per 1,000 users per day when we get to that point. And that's manageable and very high quality.
Another question. I meant the endpoint view. How much data do you have to provide per
Right, I
per
misunderstood.
endpoint?
So the endpoint sends 170 megs per day. Compressed, that's 1 to 10 to 1 to 15, and it's spread over 5 minutes intervals. So remember I said the first customer was a vessel, and they're using satellite, and they had like 30 machines on the vessel over satellite, worked like a charm. So even though 170 megs sounds like a lot, Remember, compression takes it down to 1/10 or 1/15, and you spread it out over an entire day on 5-minute intervals, it becomes very small. But of course, the data lake will have to be significantly big. 1 terabyte per 200 endpoints per month.
Okay, good. Thank you, Eirik, for an interesting presentation.
Thank you.